Our user study with 27 game creatives highlighted the importance of iterative tweaking in the creative process. Based on this insight, we identified a set of generative model capabilities that are important for creative ideation, namely consistency, diversity, and persistency. In this video, we showcase these three capabilities through gameplay sequences generated by WHAM, short for the World and Human Action Model, prompted by either only visuals or in combination with controller actions. We then showcase how these three capabilities could support creative ideation by presenting the WHAM demonstrator, a concept prototype through which users could directly interface with WHAM. We first look at consistency. Consistency means that the generated sequences should be consistent with the established game dynamics and remain coherent throughout, with no sudden changes to game characters or objects. On the left, we see a real clip of a human playing a game. On the right are visuals generated by WHAM with 206 million parameters given the same starting sequence and controller actions. We see that after only 10,000 updates, the generated character is recognizable and the basic movement and geometry are captured by the model. Nevertheless, the trajectory degenerates after a few seconds. At 100,000 updates, the model can generate longer trajectory, but the character who is supposed to fly drops to the ground. As training progresses to 1 million updates, the model starts to capture more behaviors and physics. For example, it's able to correctly model the flying mechanic. Here are more examples showing how the consistency of generated visuals increases as training progresses. We can see that in the later updates with the 1.6 billion parameter model, the map geometry becomes more accurate, the way the character moves matches with their movement in the game, and the generated visuals remain consistent throughout. Next, to assess diversity, we show WHAM's ability to generate a plethora of diverse and plausible sequences. We prompt the model with a starting sequence that places the player character at a spawn location. From the spawn location, there are three different paths to the main map: to the center, left, and right. Most players will take one of these three paths. We'd let the model generate multiple parallel sequences, and the outputs suggest that WHAM has learned to capture the wide range of human behaviors, showing diverse trajectories after the character has taken the left, center, and right path. Finally, we turn to persistency to demonstrate the level of control users are afforded by WHAM. To support creative ideation, the model should be flexible enough to allow novel modifications to the game state, assimilating them into the generated environment. Here, we modified the prompting sequence by adding an image of a power cell where it normally wouldn't spawn. In the generated sequence, the model not only retains the power cell, but also responds to this modification by creating an interaction between the character and the power cell. In the next two clips, we added a new character to the prompting frame and conditioned the dreams with 0 controller inputs, which means the player character should stand still. In the generated sequence, we see the added character persisting and interacting with the player character and the environment. With consistency, diversity, and persistency in mind, we show how WHAM could support creative ideation through our concept prototype, the WHAM demonstrator. To start, we prompt WHAM with a promotional image showing a splashy battle scene. In the WHAM demonstrator, we can generate multiple sequences in parallel, providing users with diverse options to spark new ideas. In terms of the camera angle and the user interface overlay, the promotional image is quite different from the data WHAM is trained on. Nevertheless, we see that WHAM is still able to generate diverse and plausible gameplay sequences with only one single context frame. In this first sequence, the character triggers a protective shield, hops around, and the camera angle turns to show a staircase in the background. In the second sequence, the character is being cornered by the enemy. As we see in the bottom right corner, the character evokes a special attack and starts spinning around. We also see the staircase that was featured in the prompting frame. In the third sequence, the character tries to walk away but gets attacked from afar. The stairs in the first sequence could be a good moment for a pressure release, giving the player some room to breathe. So let's pick up a controller and use controller inputs to drive WHAM's generation. We keep pressing the left joystick forward to steer the character up the stairs. Let's fast forward a little bit and see what WHAM has generated. Here, up the stairs, it'd be a good moment for an ambush. We can drop in images of 2 enemy characters and copy-paste them into the next few frames. This way, we can introduce the model to the flow of action and give it more context. Let's also adjust the controller input by steering the character towards the enemies. Now with the prompts ready, we generate the next sequences of action. As we move through these frames, we can see what's happening to the controller, for example, which buttons are being pressed and what position the joysticks are in. Let's check out the final epic battle scene we've produced using one simple promotional image. This example illustrates how WHAM and the WHAM demonstrator could support creative ideation by enabling divergent thinking and iterative tweaking.